Hey scientists, Brandon Drill here. This week in the ology Science Club, we learned some cool tricks that you can do if you know a little bit about the air. Let's get to it. Everybody knows about the air, right? We are in an ocean of air. We breathe it all day long. And that air is usually a gas. That means it's made of molecules that are moving around very quickly, billions and trillions and billions of them all around. We don't usually pay much attention because we're used to them bouncing on our body and hitting our clothes and moving in and out of our body. But we do notice them when we can get a lot of air molecules all moving in the same way. And that changing how much and how fast those air molecules are hitting is called air pressure. One way we can do that is to get a whole bunch of them in the same place at the same time. Kind of like my air Zuka here. Pretty cool, right? Now, of course, this is too big to send home with everybody, but we did send home a smaller version that everyone can try. It's the same basic idea. We've got a cup with a balloon on the end, and if we carefully pinch the balloon without breaking it, and we pull down and let go, we let a little puff of air out. Now, of course, air is usually invisible, but we have one other thing in our toolkit this week, a little cotton ball here. And if we rest it just right on top of that cup and we pull down carefully, if we rest it carefully on the top of that cup and we pull down gently on the balloon and let it go, the cotton ball flies up in the air. Here again, we couldn't see the air, but we could see what the air does. We could see what a lot of air pressure on a little space did to that cotton ball. It gave it a big push. In fact, pushing and pulling is what air pressure is all about. Now that was what happened when a very quick burst of air pressure hit a little tiny object and blew it away. We had another cool trick we tried with our straw and funnel and a very light ping pong ball. And if we can get enough air moving through the straw straight up into the air, that all of that air pressure is going to hit this ping pong ball. And because it's a sphere, all of the air is going to move around the sphere at the same time, in the same way. And that's going to float the ping pong ball on a cushion of air, so to speak. Now, as we learned in class, you don't want to set the ping pong ball down on the funnel and then blow. You have to hold it up to give it a chance to float, and then you got to blow hard. And of course, after you try a couple times, take a breath, make sure you don't get faint, because it takes a lot of air to make that float. And then we learned one other cool trick that I showed you right at the beginning of this video. If you can get your hands on one of these, a blow dryer, well, I don't have a lot of use for it in real life, but I do use it a lot in science, because this does basically the same thing the straw does. It pulls air in right here, and it blows it all out right here. So lots of air molecules moving in the same direction, and if you're very gentle, and you put the ping pong ball down above where the air comes out, you can get that ping pong ball to float in midair. And this, of course, you can do for a long, long time. And what's really cool is you can do one extra thing with this blow dryer that you couldn't do with the straw. You can actually turn it gently from one side to the other. And that's because the air molecules are moving quickly around the side of the ping pong ball. And a famous scientist named Bernoulli taught us Bernoulli's principle. That is that fast-moving air creates low air pressure. That means there are less molecules pushing on that ball at any given moment than there are just randomly bouncing around it. In other words, as the ping pong ball tries to fall, the higher air pressure around it actually pushes it in place. It holds it up even though the air isn't blowing So even though the ping pong ball tries to fall down, as gravity pulls it, the heavier amount of air molecules around it basically pushes it, holds it in place. That's not the only cool trick we learned using air pressure. Another cool thing we can try is to take this small glass right here and this waterproof playing card. And we're going to just pour a very small amount of water into our cup. Now, of course, you might want to do this near a sink or somewhere where it's easy to clean up. And then we're gently going to rest the playing card flat on top of the cup. Now, once you have your playing card resting on top of the cup, you need to make sure there's no holes where the water can leak out, because we're going to take that cup of water, we're going to rest our other hand flat on top, we're going to flip it upside down, and we're very slowly going to take our hand off of the playing card. The water doesn't fall out. And this is because of air pressure. In other words, there's about the same amount of molecules running into the outside of the cup and the outside of the card when it's tipped upright. But right now, the water is pulling down, and that creates a slightly less amount of air molecules running into the cup and into the water inside of the cup. That means there's lower air pressure, and on the outside of the cup, there's higher air pressure. And all those molecules on the outside of the cup that are banging into it are actually holding it all in place. But of course, if you move the card gently and a drop or two of water spills out, air can rush in, and then the card will fall, and all of the water will spill out. We learned one last cool way we can demonstrate this with this little tube. Now, this little tube isn't enough. You're actually going to need 2 empty bottles and some nice strong tape, some nice waterproof tape, duct tape, aluminum tape, something like that. And what you'll do is you'll fill one bottle up with liquid, and I've added a little food dye here. You could put glitter in if you wanted to make it a little more decorative. You'll screw this tube right onto the top of that bottle, and then you'll take another empty bottle and screw it onto the top. So you see the tube is in the middle, you've got a bottle on either side, and then you're going to wrap some nice strong tape around both ends of the tube. These tubes are cool, but they do leak, and that can be messy. So put some nice tape around the edges, and then you got to ask yourself, how can we get the liquid from this bottle into that bottle? And the answer, of course, is flip it over. If we flip the whole thing over, gravity should pull all the water from this bottle down into this bottle. But we notice when we do that, the water stays put. And that's because we learned, of course, this bottle is not empty. There is air in this bottle, and that air is pushing up while the water is pushing down. And they're balanced. Neither one can move. In order to get the water from this bottle into this one, we would have to somehow create a hole so that the air could go up and the water could go down. To do that, we're going to hold the middle as still as we can. We're going to put one hand on top, and we're going to give it a spin. Give it a circular spin, and then stop. And when we stop, the water is going to continue to move around the sides of the bottle, and that's going to create a vortex. The vortex is going to be a hole through the water that's going to allow the air to go up to the top and the water to go down to the bottom. So that's it for this week's Woology Science Club. I hope you had a lot of fun learning about air and air pressure and Bernoulli's principle and vortexes. And as always, do more science, have more fun.